present our guest speaker today, UWA Latacz-Lohmann, to the extent that we've been working together since 2003, actually. So UWA has come here for 3 weeks in order for us to finish a long-standing paper which we've been working on often till about midnight, I'd say. And also because he's here as a key partner investigator on our ARC project on conservation auctions. I did tell him before he came to bring his trailers, because it would be nice weather and we could go to the beach and do things, but he hasn't even seen the beach. I therefore feel very, very guilty. Hasn't done anything except work, even when I did take him down south. Anyway, so UWA has been an adjunct to the school for many years, and we have been working together, and now also including Said, is he here somewhere? I can't see this here. In the work, trying to advance this area of conservation contracting, in this case, and auctions at the same time. So thank you very much for having come. Because he's part of the ARC project, and within it there is an international collaborative fund that funds his travels, and Peter Boxall's as well. We will see more of him in the next couple of years, as we will see Peter Boxall, who will be here in the first week of May. So thank you for coming, and thank you for giving us the
Thank you very much, Stephen. Welcome, everybody. It's not quite true that I haven't seen the beach. I've seen the beach of Matilda Bay, which is beautiful and does the job. Well, once again, thank you very much for inviting me and for the great hospitality I have experienced during the last 3 weeks here. I'm going back tomorrow. Well, I'm not going to talk about auctions, which is my main topic, really, conservation auctions. Today I'm talking about an alternative to auctions. And before I start, let me acknowledge the contribution of Norbert Schulz, who was my PhD student, he has finished, and Gunnar Breustedt, who is also in my department, for having contributed substantially to this paper. They have done the econometrics. I'm not really an econometrician, and hope not to be asked too difficult questions on the technical side of the paper. I've had the general idea and have set them to work, and they ran with it and did all the number crunching. Well, what is the problem we are addressing? I said I'm not going to talk about auctions or actually self-selection contracts. These are two mechanisms for improving the performance of conservation contracting. So this has been emphasized or advocated in the literature. If you want to address the hidden information problem, the problem of adverse selection, you as a policymaker should either use self-selection contracts in which different types of farmers select or always have the incentive to select the contract that is meant for them, or you can improve the cost effectiveness of auctions or address the adverse selection problem by putting conservation contracts up for tender. And I'm looking at an alternative to these two mechanisms, which is gathering of information. So the regulator goes out and carries out a discrete choice experiment with farmers to gather information, which is then used to inform the design, the optimal design of environmental conservation contracts. So it's about contract optimization using information from a discrete choice experiment. That's the basic idea. Just doing away with auctions and self-selection contracts because they really don't work well in practice. So these are the two objectives: to demonstrate how not a standard discrete choice experiment, but a purpose-made two-stage discrete choice experiment can be used to inform the design of agri-environmental contracts and to investigate the effect of the information from the discrete choice experiment on the performance of the policy in terms of value for money. Can we really improve value for money, or by how much can we improve value for money by going out and eliciting some information which we then use to optimize contracts? So the whole analysis comes on this slide. It's a 6-stage analysis, and I'm going to show you the 6 stages first, in short, and then elaborate on them. So the first step or stage is to carry out a standard discrete choice experiment where we try to establish the factors that determine contract choice, whether a farmer chooses a contract, a conservation contract, or not, with given management prescriptions and a given payment rate. So that's a discrete choice experiment.
It's a fixed payment determined by the agency, isn't it?
Yes, yes, exactly. And then we extend this choice model to account for the contract area, to be able to explain which factors, contractual obligations, payment rates, and also farm and farmer characteristics determine the contract area chosen. So it's not only contract yes or no, but also how much land to put under contract. That's the second stage. That's the extended discrete choice experiment. Then we introduce a third element, which is an environmental benefit function, which effectively translates management prescriptions or conservation activities into environmental outcomes measured by an environmental benefit index, right? And if we now multiply 2 and 3 with each other, we get something which I've called environmental service provision. Well, actually 1, 2, and 3. The product of 1, 2, and 3, contract choice times contract area times the environmental benefit per hectare is what I called environmental service provision. And the next 5th step then is to optimize contracts in the sense what is the optimal combination of conservation activities, management prescriptions and their levels chosen, and payment rates, so as to maximize environmental service provision with a given budget. So that's the objectives. There's an optimization exercise at the end of this. How can we use the information gathered from the discrete choice experiment to optimize contracts? And there's a little optimization module. And then finally, I want to compare policy for performance in terms of value for money of these optimized contracts versus a standard contract. And a standard contract is one where the regulator offers a fixed payment rate for all farmers. It's a just take or leave decision for the farmer. A fixed payment rate which I've assumed to be at the level of the average cost of all participating farmers. So I don't know whether we'll have time for the last point, but the other ones are also more important. So what are the relationships here for the two, or for the 6 stages? The first stage, as I said, we wish to determine which factors, which variables determine contract choice and contract area. And these are, of course, the conservation activities prescribed in the contract, right? How demanding they are. It is the payment level offered, A, and it's also the farm and farmer characteristics that affect these two choices, farmer choices. Well then, stage 3 is the transformation function which translates the contract variables, the conservation activities, Z, into an environmental benefit index per hectare. This is pretty arbitrary. We just used some function to illustrate, for illustration. And environmental service provision then, as I said, is the product of contract area and environmental benefit per hectare. And so this is total area, the product of total area under contract and environmental benefit index, and total area under contract is a function of the contractual obligations, the payment rate, and the farm and farmer characteristics. And then finally, that's the optimization exercise. I wish to maximize environmental service provision subject to a budget constraint. And these are the decision variables of the model. You see, it is the contractual, the conservation activities, the management prescriptions, the stringency of management prescriptions, and the payment rate. So, yes?
On the Zs, is it a take-all, or can each respondent in the CE choose a different vector of the Zs for their...
No, it's uniform.
They have to take
they,
1 through 5.
yes, yes.
Okay.
Just one clarification
Yes.
question. The Zs, which are particular management prescriptions,
Yes.
are they assumed to have the same costs? Because different farmers on different soils doing the same matter could
No.
actually have different costs.
Yes, of course. This is a discrete choice experiment, and farmers will consider what is my cost of, for example, delaying the mowing of my grassland. That's one of the management prescriptions from, say, end of May, which is normal, to end of June. And they would work it out for themselves, and that would influence their decision, their choice. I'll show you. I'll show you the standard discrete choice experiment we carried out. So we had 3 contracts and an opt-out option, so no contract. And here are the conservation activities, the management prescriptions. They relate to the types of fertilizers that may be used. This program is actually designed to enhance, ground nesting birds on permanent grassland, on wet permanent grassland in the north of Germany. And these are the management prescriptions, so set mowing dates, maximum stocking rates, which type of fertilizer farmers are allowed to use. Then another variable is the contract duration, varying from 1 year to 10 years, and the annual payment, compensation payment, that is offered. And farmers simply have to choose one, just have to tick one box there, one of the 4 options. Right, that's the standard choice experiment, which allows us to establish the factors, the variables that determine whether a farmer participates or not. We've extended this, as you can see, by requesting a minimum of the permanent pasture of each of the farm to go under contract. Right? So this is minimum of 5%, minimum of 10%, minimum of 20%. These are, so to speak, fixed labels. And the other extension then, of course, is that the farmer not only chooses one of the contracts, but also indicates how many hectares he would put under contract. This will allow us subsequently to establish the factors that determine the contract area, the area of land under contract. Right? Well, these are the attribute levels we have chosen. Set mowing dates, as I said, not before the 1st of June or the 22nd of June. This is when the 22nd of June is when the birds fledge. Maximum stocking rates, contract duration. So this was all varied systematically. We generated an efficient design. And the survey was carried out in northern Germany with 68 farmers, face-to-face interviews. Each farmer had to go through 8 choice sets, and we had these 2 variables, the contract choice as a binary variable and the contract area as a continuous variable, and the survey also established or gathered information about farm and farmer characteristics as independent variables for the estimation. And this is then what you get from the first stage results. So you get marginal effects and willingness to accept estimates. For example, if you allow the use of organic fertilizer against the benchmark of no fertilizer, then you have to pay 162 euros per hectare less to attract farmers. If you allow organic and mineral fertilizer, then it is 214 euros per hectare less you have to pay. If you, by contrast, delay the mowing date by 1 day, you have to pay an extra €4.16 to have the same probability of contract choice. So this is the results from the first stage. And then, well, we also did this for farm characteristics. Farm characteristics also affect the probability of a contract being chosen. For example, if you look at this one, farmers who are already experienced with participation in agri-environmental schemes, you have to pay 106 euros per hectare less because they already know how it works. They have learned the technology, and you can buy them in for 100 euros per hectare less money. Likewise, if a farmer has high stocking rates, many livestock units per hectare, you have to pay more, right? So that's the farm characteristics. And then you could do something which is ethically questionable. You could calculate for each individual farm their cost just by plugging in their individual farm and farmer characteristics, right, as long as you can observe them, and the contract variables, how demanding you make the management prescriptions. And this then has to be, this is the willingness to accept estimate, which I interpret as the perceived cost, not the true cost in terms of income foregone, but the perceived cost of participation. And this must be less than the payment for a farmer to have an incentive to participate. And this, of course, you could do for all the farmers and could offer a payment that exactly equals cost. Ethically questionable. That's why I didn't pursue this route any further.
But you don't have an ethics committee. So
Yeah, that's...
They would tell.
Well, what I did is I used this information to estimate the average participation cost. For example, here for contract 1, it's 323 euros per hectare. Across all farmers, 68 farmers who participated. Right? The lowest cost was 0. So there were some farmers who already apparently managed the land in a way that was consistent with the requirements of the contract. And the highest cost was nearly 800 euros per hectare. So quite realistic estimates, actually. Now, this is the more complicated stuff. The second stage estimation, where we try to establish the determinants of area under contract, right? And what we do is we do a standard OLS regression, but we need to include correction terms which account for the correction of correlation between right-hand side variables with the error term. And you normally do this by using, well, the inverse Mills ratio, but we used the Durbin and McFadden method with to correct for the selection bias. This is how it works, and I really hope you don't ask me too difficult questions about this. This is, well, yes, why you need good PhD students. And this is the results of the second stage. So the dependent variable is the contract area, the area of land under conservation contracts. And you see this is a function of the contract attributes, of farm and farmer characteristics, and of these correction terms. And if you look carefully, which you don't have the time to, you will see that the contract attributes are not significant. Their significance is taken up by the correction terms, right, in this estimation. And what we then get is a contract estimate, a formula for estimating contract area for individual farms, just in the way as we were able to estimate willingness to accept figures for individual farms. We can now estimate contract areas for individual farms by simply using the coefficients from the OLS regression and plug in the farm characteristics, the S values, and the correction terms. And then we get, for each farm, an estimate of the contract area for a given contract with given management prescriptions. And then we can sum this up across all participants in the survey, and then we get the total area, land area under contract. And we do this for the different contracts, right? So we have the total area under contract, and if we multiply this with the environmental benefit index, which comes next, I think. No, well, what we get is a supply curve. The supply curve land area under contract as a function of the payment you offer, the willingness to accept, the cost, marginal cost, you could say. So that's the supply curve we get out of this for the 68 farmers. When you then multiply this by the environmental benefit index, then you get a measure of environmental service provision. And this is, well, as I said, this is very crude and arbitrary. Here we have, I've just shown a few transformation functions, transforming management prescriptions, management activities, conservation activities into environmental outcomes measured by an environmental benefit index score. So, for example, if you reduce your livestock units down to 1, this will yield 0.75 units of environmental benefits. Very crude. We just did it for illustration purposes. The longer the contract, the higher the environmental benefit index. If you the further you shift the mowing date into the future, the higher the environmental benefit index, because then you can be sure that all the birds will have fledged. Okay? Now take the product of this and that, and you'll get a measure of environmental service provision. Oh, yes, environmental service provision. And then, that's up there, we use this formula, this estimate of environmental service provision. Once again, it is the total area under contract, which is a function of the management prescriptions of the contract, the payment offered, and farmer characteristics, and then multiply this by environmental benefit index yields environmental service provision. This we then want to maximize given a budget. And the choice variables of the model, oh, here's a stick, which is good, are the management prescriptions and the payment rate. Right? So the model says choose the level of management prescriptions and the payment rate such that you maximize environmental service provision given, where's the budget constraint, given a budget, right? And of course you have to constrain the model, for example, well, to take into account realistic management prescriptions. For example, the set mowing date. We said, well, this can be, that's variable Z3, this can be between 0 and 31 days after the 25th of May, right? The stocking rate can be between 0, no animals, and 4 livestock units per hectare. Contract duration can be between 1 year and 10 years. The maximum payment per hectare can be between 0 and 650, and so on. And organic fertilization can be either permitted or not. So this is a binary variable. So that's the model, maximizing or choosing the management prescriptions and the payment rate such that environmental service provision is maximized, given a budget. And this is what you then get. We did this for the 3 different contracts, which requested different amounts of permanent pasture being put under contract, 5, 10, and 15% minimum. And what we get is here environmental supply curves, optimized environmental supply curves as a function of the budget. We can parameterize the budget, and then we get these supply curves. And you see, well, for example, contract 3 always comes out at a higher environmental service provision, a higher quantity at nearly each budget level, right?
A quick question.
Yes.
So, but we don't know that the actual value of those environmental services exceeds the budget, right? I mean,
No. There is no valuation of the benefits. No, it's just the regulator's objective is assumed to be maximize the quantity of environmental benefits, no matter how it is valued, within a given budget. Right. And now, what do optimized contracts look like? That's the important question from the point of view of the regulator. And how do they respond to the budget? I've shown here 2 optimized contracts, one for a budget of 150,000 and one for a budget of 300,000. And as you can see, permitted fertilizer, if you only have 150,000 for the 68 farmers in the sample, the optimal Z1 variable, fertilization variable, is allow organic fertilization. If you have more money, restrict or set fertilization to 0. Don't allow any fertilization. Stocking rate doesn't change. The set mowing date doesn't change very much, but if you have more money, you make it a bit more stringent. Contract duration doesn't change. The payment per hectare does change. You pay much more if you have more money, but you only attract 3 more participants. 3 more participants doesn't sound that attractive, but if you look at the environmental service points, you do get a lot more because the selection is different. If you choose this specification, contract specification, you do get only 3 more, but you get those who provide a higher level of environmental benefits, the environmentally more productive farmers, the better types, if you wish. And the total contract area doesn't change very much either. That's at least what the model says, the optimization model. And what I then finally did is I estimated the performance of optimized contracts in the way I've just shown you in relation to what I call a standard contract. And a standard contract in Europe is a contract which offers a uniform payment equal to the average opportunity cost, participation cost of all farmers. So that's how it is done in Europe. Fixed price scheme set, where the fixed price is set at the average estimated opportunity cost of all farmers. And we compare this to an optimized, we compare our optimized contracts to this standard contract and in addition to a full information contract where I did what I said would be ethically questionable. I did it, offer every farmer exactly his cost, right? And this is what we get. If we just look at the outlay per hectare, the cost effectiveness on a per hectare basis, I've always put the optimized contracts in the middle and set it equal to 100, right? So what we pay here in the optimized contract is 245 euros per hectare, in the standard contract, we would have paid 323. That's the average opportunity cost. So we pay less per hectare. Of course, in a full information contract, we would pay even less, but we can't do that. Now, if you look at the number of participants, you will again see that with the optimized contract, you select fewer participants than with a standard contract, but you select the better ones. Well, we will see later on. And you will actually get a bit more, land under contract. So you apparently select fewer farmers, but farmers with more land, who offer more land. And as you can see here, environmental service points, with the optimized contracts, you gather within a given budget 1,209 service points, as opposed to 924 with a standard contract. So that is an improvement. Here's the relative figures. Of course, we don't reach to the super optimum, full information optimum, but we are sort of halfway in the middle. So my conclusions from this is, yes, discrete choice experiments can generate useful information to calibrate agri-environmental contracts ex ante, before the scheme is put into practice, into place. The value of the extra information, well, it's a very rough estimate in the way we did it. We have estimated the value of the extra information by comparing the optimized contract to the standard contract, and this is about 78, a cost saving of 78 euros per hectare, or roughly 25%. So you get the same amount of environmental benefit for 25% less if you go out as a regulator and gather information and use it to optimize contracts. The value for money advantage, this 25%, is in the same order of magnitudes as that for conservation auctions, where we established through experiments, also through field trials, a range of 10 to 40%. So it's the same order of magnitudes. It's important to have a representative sample, which I think we had for the area, of course, only for the area. It's, you do it, well, at least in Europe, you have to do it small scale, because many schemes are really regionally targeted on specific environmental outcomes. And therefore, because these are specific schemes, results cannot be transferred to other schemes or other sites. So, and the purpose was not really to come up with these quantitative estimates, which are really not reliable. I wouldn't trust them. But to demonstrate that discrete choice experiments can be used in a useful way to calibrate agri-environmental schemes as an alternative to auctions or self-selection contracts. And that's all I have to say. Thank you very much.
Any questions? It was really interesting to know that actually a choice experiment is useful.
First time.
Michael.
So I want to suggest that your choice experiment isn't really useful. So this is the incentive compatibility question, which I'm sure you've heard before.
Yes.
Even they didn't know what these were going to be used for. But if you were to suggest this as a real policy framework, you would be suggesting that it should be rolled out over a bigger set of farmers. They would presumably know what this is about, as in that the objective of this is to use this to design the contract. Even if you designed it so it had all the right properties, it was only a binary choice, it was one shot, there was no repeated choices, it was the best that you could do for... Is it still incentive compatible in the sense that they know that they're going to be getting an offered a contract later on?
No, it's not. Of course it's not. It's not incentive compatible, because there will always be...
Useful. My conclusion was correct.
Be careful, Michael. In that case, none of the choice experiment literature is useful.
Yeah.
This is particularly focused, that they're asking people to help you design a contract which then they're going to later come back and...
Well, you could do it, for example, with a sample of farmers, not in the area in which you wish to implement the policy, but in an area with similar resource settings, permanent pasture, and tell the farmers, oh well, we're just doing it because we love discrete choice experiments, right? And this is a new method we want to work out to see whether it works. So this way you could probably decontextualize it and try to elicit true responses, I suppose. This is what we actually did. We hid this discrete choice experiment in a broader survey of farmers. So we made farmers believe we are really, as you said, we don't have an ethics committee. We made farmers believe we were after something completely different, right? And then we hid this in there, and yeah, that's what we got. But of course, it's right. We must be careful and have that in the back of our minds, that it is not incentive compatible if you give farmers the information, tell the farmers the purpose of the survey.
Should the survey, couple of questions, should the survey always include a do-nothing choice? Did your options?
Well, that implements really the voluntary character of conservation contracting. It's not statutory regulation, so farmers don't have to take a contract.
But did you answer that question, though? Or was that one of the options?
That was one of the options.
Yeah, okay.
You can always opt out.
Go on to the second question.
Yes.
How do you cope with differences in duration? Did you make it so that a farmer that just chooses 1 year has that contract repeated, so that they're comparable with a farmer who opts in for 5 years?
No, if it specified 1 year, then the farmer is out after 1 year. Right? So it's only for 1 year, giving him flexibility to do something else with the land.
So did you evaluate contracts as being, so you have two farmers, one's in for 5 years, so you
Yes.
evaluate the contracts over 5 years, but you have one farmer who goes in for 1 year and then he's out for 4 years?
We didn't specify that. I think we could say, well, you can come in after 1 year. You can come back in. You can renew your contract after 1 year. That's what you had in mind.
I'm just wondering how you're comparing different durations of contracts in terms of their environmental benefits.
Oh, well, it translates into a different environmental benefit index. So that's one of these transformation.
So if it's just shorter contract, it's worth it.
Yes, look, contract duration, 1 to 3 years, 0. Right?
I have a question extending on Michael's concern.
Yes.
Is like you have designed this, like optimized the ideal contract, but what is the probability of that contract being accepted by your farmers? And that so since you are comparing with auction, in auction like they are submitting their bids, so they know that if it's accepted, then I'm going to implement it. But here you are identifying optimal contract. And so there is no guarantee that the respondents will say, I will accept it.
No, these are expected values. We are working with probabilities of acceptance, which are generated by the model. So the model tells you.
The reality is when you go out,
Yes.
and you make a whole series of offers,
Yes.
only 80% of them will be accepted. So because of the error in the model.
Yeah, no, well, because of the budget, I suppose. Not.
The farmer just might say, no, you've offered me €100. That's not enough. I need 150.
Yes.
When you set this up, is it on a knife edge that if the amount you offer is slightly more than the amount they're willing to accept, you're assuming they will accept it? You're not using the probability they'll accept this contract?
The probability. We're using the probability.
Out of the choice experiment.
Yes. Wait a moment. Yes, we do. We do the probability from the choice experiment. Because that affects the how shall I say this? The Z variables and the S variables affect the probability of a contract being chosen and the probability of a certain amount of land being offered. We aggregate, well, in calculating the total area under contract, now I must say I don't completely remember. I think we use expected values, expected total area under contract.
The probability accepted contract, doesn't it depend upon the other contracts you've offered me and the characteristics of the other two contracts?
Yes, that's what we account for through the correction of the selection bias.
What do you then, your contract optimization, no, I can't do this. This is a lunchtime conversation.
Okay. Dave.
So you made a comment about your price discrimination option as being immoral, but I put to you that morality and ethics are in the eye of the beholder. As Steve will attest, everybody's got different attitudes to what constitutes a fair outcome. And I thought to suggest an alternative concept of what could be considered fair, which is that everybody gets the same markup above their, reservation price.
Yes.
So you could say, okay, we're going to price discriminate, but everybody gets a €30 per hectare profit. So that's fair, because it's getting the same profit.
That's
We don't know whether it's a profit.
Oh, well, sure,
yeah. So that's one notion of fairness.
You've got such a lot of benefit to play with there. I mean, I must say, I agree with Michael. I'm worried about the whole scheme because of that reason that it doesn't work. But if it can, you've got such a lot of upside to play with there that you could afford to offer.
Yes. But I mean, it's
actually this thing. Following up on this, is there a way using this study to say, if I offer using the optimal contracts, if I offer a payment that is X above the so-called optimal, how does the probability of acceptance increase? And so say, if I want a 90% probability of acceptance, by how much should I actually put that markup?
Yes.
And so there's a trade-off.
Yeah, sure. We could, I suppose we can work it out. Yeah, exactly. And coming back to your point, I was wrong about the probabilities, because just going back to this point, we always had the binding constraint that the payment must be, it's a knife edge. Yeah.
Did you have any independent estimate of the Zs for the area, like through mapping, and did you know the land base and what the environmental characteristics were? So another way to get at Michael's question would be how, are the farmers, are what you're getting out of the estimation compatible with the, quote, objective measures of the environmental services?
Yes, we were. The design of this experiment was very much targeted on that particular area, taking into account the resource settings in that area. And we actually calibrated the conservation program from another scheme which is used somewhere else but under very similar resource settings, and to test it on farmers in this area in the north of Germany.
So how close was their response rate to what you thought were the optimal? I mean, you could have a totally independent of preferences determination of how much pasturage we want to protect. Did you go back and look and see whether there was any compatibility between
we
those,
didn't.
or they're just outright lying?
No, we didn't.
I mean, it might be something to look at on
Yes,
sample.
that's a good idea.
Last question.
Oh, well. Just one comment following up on Michael's, if they know, this is a general thing, following up discussions I've had with Michael, many months, if they know where this is going, you're going to have an incentive compatibility problem. However, if you don't tell them, and it's sort of, you're interested, then you have the opposite problem, which is the consequentiality problem. And you're going to be bounced from one to the other. Consequentiality meaning that they're going to answer randomly. They're not going to really represent the
Mm.
preferences.
Yes.
And so you're caught between strategic answering and
Well,
quasi-random.
Random,
answering.
yes.
Though whether you can test for that and
Yes.
whether there are special statistical tests, I'll ask the statisticians here, whether you can test whether that's
Mm.
the case or not,
Mm.
I'm not sure.
Well, no, I'm not aware of any such tests, but I think it was consequential because farmers, well, many of the farms were located in a Natura 2000 area, designated nature conservation area, and they were aware of such schemes, and they were actually facing mandatory statutory regulation relating to the management of the land. So they are very, very much familiar with the conservation technology. So I think it was consequential, but there may have been a strategic bias involved.